Algebra Half students. We're back with lesson 114. Can you believe we only have 14, 15, 16, 17, 18, 19, 7 lessons to go till we get to the end of the book. We'll do 4 this week, 3 next week, and then we'll do some review and reinforcement for the final. And then we're done for the year. I hope you're excited. Hopefully you saw the video that I posted that explained that problem 11 in lesson 106, which was a doozy. But we figured it out. We got to the right answer, and hopefully that made sense. Always make sure to check those units because they do try to use those to confuse us and trip us up because remember, math people are jerks. So, lesson 114 is our part 2 on probability. Last probability lesson was dependent events, and this lesson is independent events, which means that we're going to be using a lot of things like cards and putting the card back in the deck, or dice, or flipping a coin, okay, because there's always just 2 heads to the coin. So remember, probability is the likelihood that something is going to happen, and an independent event means that it doesn't depend on anything else, okay? So like I said, a coin, when you flip it, is always going to have 2 sides. There's no way to change that, as opposed to the difference with like taking the card out like we saw last week, or taking the marble out and not putting it back in. Those are dependent events. Independent events are ones that cannot be changed. Okay, so the example that they start to give us is, it says the diagram tree demonstrate probability of independent events occurring in a designated order. The first diagram shows the first possible outcomes of a coin toss if it's tossed twice. Okay, so if we toss a coin twice, the first time, what are our choices of what could happen? Our events could happen. We could get heads, or we could get tails, right? And then our second toss, we could get heads or tails, or heads or tails, right? Because if we get heads first, the second one we could get heads or tails. And if we get tails first, the second one we could get heads or tails. So this is first, and this is second, okay? And so they're trying to show us that the probability of getting, it says on a single toss, the probability of getting heads is half, right? 50%, 1 out of 2 times. The probability of getting tails is also half, 1 out of 2 times. There are only 4 possibilities on 2 tosses. The first toss is heads. The second toss can either be heads or tails, right? So the probability, and they note it by saying P, the probability of getting heads. Okay, so first, what's the probability of us getting heads the first toss? It's 1 out of 2, right? And then what's our probability of getting heads on the second toss? So now we're just looking at this section. Our probability of getting heads on the second toss is another half, right? So the probability of getting heads and then heads again is 1/2 times 1/2, which we know gives us 1/4, right? 1 times 1 is 1, 2 times 2 is 2. Now, what's the probability of us getting heads and then tails? Okay, heads again, 1/2. And then tails the second time, 1/2. So 1/2 times 1/2 is 1/4 of the time we will get heads and then tails. Now, the same thing is true for tails, right? So if we wanted to see if we could get tails, it'd be half times half. Tails, heads, half times half. I'm not going to write that out because I think it's pretty much self-explanatory. So we're going to go to our first example, which is 114.1. And it's telling us that we are going to be tossing a coin. A fair coin is tossed 3 times. What is the probability that it will come up heads every time? Okay, so we could draw out the diagram again, right? So the first toss, so we're going to do the probability of heads, heads, heads. Okay, the first toss, we could get heads or tails, so that's going to be 1/2, right? So I'm just going to stick with heads now. Now, what's the probability of me getting heads on the second toss? This is 1, this is 2. Again, it's 1/2, right? And now we're going to just stick with the heads. What is the probability of me getting heads on the third toss? It's still 1/2, okay? So are you seeing a pattern? Every time we're talking about coins, flipping coins, it's always going to be 1/2 times 1/2 times 1/2. All right, 1 times 1 times 1 is 1. 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. So the probability is 1 out of 8. If you know your decimal percent fraction equivalents, you know that is 0.125 or 12.5%. Super fun. All right, so let's keep going. I believe there is one more example for us. All right, and example 114.2 says a fair coin is tossed. A fair coin is tossed 4 times and it comes up heads each time. What is the probability that it will come up heads on the next toss? Okay, so they're giving us all this information that we don't need. We've flipped it 4 times, we've got heads each time. Throw that information away. All they want to know, what is the probability of getting heads on the next toss? When we toss a coin, we always have what probability of getting heads or tails? It's always 1/2. All right? So don't let them, again, be jerks and try to confuse us. Make sure you read through the questions real good and weed out what they're actually asking for. You have 2 practice problems with probability. Probability can be kind of confusing, so that's, I think, why they save it to the end. It's a little more difficult, and you will do it again next year, and the next year, and the next year. So don't worry about it if you don't completely understand it, but just remember to think through critically the likelihood that something can happen. Remember, the numerator is the times that it can happen, and the denominator is the total number of outcomes. So on a coin, heads could only be 1 out of 2. On a dice, the number 1 could only be 1 out of 6. And then when we're doing independent events, we're going to always be multiplying the likelihood of that thing happening by the different fractions that we form based on the information that we have. So hopefully that made sense. Don't hesitate to reach out.